Okay, recording now. Back to this. All right. All right. Just recap a little bit. We didn't have a lot of time last Monday, so we don't have a lot that we talked about. But just to bring everybody back to where we were, give examples of tests what we would want to do in case of product development, competition, change in process, or food forensics. So try to type in the chat, and for every answer, say product development and list some tests, competition and list tests, change in process, and food forensics. So choose one of those and answer. Let's see what we have here. Okay, they are coming in. Shelf life for product development. Yes, if we're changing content, we want to see if the content, let's say if we changed fat, type of fat, we want to do that. Yes, competition, reverse engineering. I see a lot of competition, reverse engineering. Food forensics, microscopy, yes. Sensory tests for product development. Fat analysis, if it's specific, if we're doing anything specific in product development that involve changes in fat, yes. If not, it's not a necessity. Water activity, it could be depending on the product itself. Oxidation, again, if there's anything related to fat. Shelf life, package design. Yes, if we're changing anything in the package, that's exactly, yes. Food forensics, if there's any adulteration, yes, and we have to do either microscopy or spectroscopy to look at that. All good answers. So good. Microorganism tests, well, I don't know where that falls under. We always want to check product safety, but I'm looking for anything we would do that is specific for any of these situations. All right, so this is all good. I'm glad that you guys are on board and gave that a thought. Okay, so moving on to where we were. So as food analysts, what do we need to know? So we are food analysts in a company, in a research lab, in a government lab. So what do we need to know? We need to know what type of test or analyses needs to be conducted. And the type of analysis is really dependent on the objective and the type of food. So why do we want to do analyses? Is it to do it for nutrition labeling? Is it for quality assessment during production? Are we looking for contamination and residues of concern? So what is the objective? And also, what is the type of the food we are working with? And I'll give you an example for type of food specific situation. So we really need to know what's the objective and what the type of food, and then we will determine what type of analysis. So that's the first question we ask. Okay, what do we want to analyze? And then we go and see, okay, now we want to choose a method. During the entire semester, we'll learn about methods. And you will see that sometimes you have multiple methods for the same type of analysis. So how do we choose the method? Well, we choose it based on different components. Is it going to be for nutrition labeling? We have to go for official methods of analysis. And even under official methods of analysis, you have different methods that you can choose from as well. Let's take moisture analysis, for example, and we'll learn about that in class later on. Official methods of analysis for moisture can be vacuum oven, can be forced draft oven. So there are two different ovens methods that you can use, and both are official. Which one do we choose? Then we go, okay, depends on the type of product we have. Is it high in carbohydrate? Is it high in moisture? Is it high in fat? So which one of these methods would be best suited for the type of product we have? And sometimes you are restricted by what you have. I only have a vacuum oven. I don't have a forced draft oven, for example, so I'm bound to using that one oven method. So choice of method is another thing that you would want to be able to determine. And again, you will learn throughout the semester different methods and how we choose specific methods for specific analysis. We have a chapter on sample selection and preparation. This is chapter 5. So sometimes you have a large amount of sample that is given to you to analyze. Maybe 100-pound bag of flour. Do we subject the entire 100 pounds to analysis? No, we have to select a representative sample to subject to analysis. So we learn in chapter 4, how do we select a representative sample from a big lot that would give us an estimation of the situation or the quality of the entire lot. And then how do we prepare the sample so that we have accurate results? A lot of the errors that sometimes lead to inaccurate results and misleading decisions, wrong decisions, is due to how you prepared your sample. So during sample preparation, there are cautions that we need to take, or precautions, to prevent changes in the sample that would lead to inaccurate assessment. That could cost you money, because if you reach to a decision that we need to reject the lot, and the lot is good condition, but you decide to reject it, that is waste of money for the company. So this is very, very important. And then analytical techniques. Analytical techniques is you want to learn how to actually execute the analysis or conduct the analysis. So you want to learn the methodology, and you want to be able to operate certain equipment. So you want to learn how to operate that, and then be able to produce data that you can analyze. So the analytical techniques, we will learn about them throughout the semester, different techniques, and you'll have the opportunity in the lab to actually have, hopefully, some hands-on experience to conduct these analyses. And then once you have the data, you should be able to learn, or we're going to learn how to analyze this data, make sense out of this data. What does that data mean? What does it tell us? How can we analyze it in a manner that is objective, not subjective, so that we can make decisions? So there will be chapter 4 on data analysis. And in terms of interpretation, every lab we conduct, we have set of data. We kind of guide you through how you're going to interpret results. What do you want to compare them to? What are their meanings, and what would they tell you? So different data sets will have different interpretation, and you learn that throughout the semester through the lab exercises. Finally, you would want to make a decision based when you're working in your workplace, a company, in a research laboratory, or government labs. You want to make a decision based on your data, and that decision can cost the producer or can cost the consumer. So if you make wrong decision and the product goes to the consumer, then the safety of the consumer is jeopardized. Or if you make the wrong decision and the lot is being rejected, then you caused losses, economical losses to the company. So decision making is very important aspect of the whole process. Okay, what I'm going to encourage everybody, if you have any questions, in a classroom setting, I see you, and then you can raise your hand and you can ask questions. In the Zoom setting, it's really hard to gauge if you're with me, if you have questions. Sometimes I look at you in classroom, I know that you need me to repeat something. So please use the chat box, and if I'm not looking at the chat box, Rachel or any other TA attending the lecture will just yell my name and I'll stop to answer a question. So please use that chat box in the Zoom medium, and hopefully if we get to class, I can interact with you better and see you and get cues from you. throughout the process of setting up the analyses, methods, collection of sample, running your analytical techniques, interpreting your data, and then making a final decision, we have to keep in mind government regulations. So selection of the method, depending on your objective, there are government regulations sometimes that you have to abide by. So if you're doing nutrition labeling, you have to use official methods of analysis, and we'll talk about that in a minute. So there is no way around that. If you're doing nutrition labeling, you have to select official methods of analysis. Also, in terms of decision making, whether to reject or accept a lot, there are regulations along these lines too. Sample selection, how you're going to select a sample randomly, how many samples you're going to take out for analyses like your replications, for example. So, and how you're going to prepare your samples, you have government regulations to follow. So that's why I have it in the middle in red. We have to keep in mind government regulations stated by the FDA or FSIS and all the regulations. Usually you can find them in the Code of Federal Regulations. So I was telling you, yes, I think I kind of answered this earlier, is like type of analyses to be carried out is determined based on. So let's see if I can get you to answer this question. So type of the product, health claims, or purpose. All right, let's see. So we're all agreeing on F. That's good. I don't have to type it anymore. I think there is good consensus here that it is F. Good. So yes, I did mention that the type of the product, what product, is it a product high in fat? So do I really care about rancidity or not? Is it a product that I'm going to claim for as a high fiber source? Am I going to make such a claim, a health claim, that I need to look at the composition of the fiber or dietary fiber? Is it purpose? Is it for quality control? Is it for nutrition label? Is it for shelf life? So that all of these factors take place or take role in determining the type of analysis.
Is it all of the options or just A and C?
Oh, F was A and C. I'm sorry. Thank you, Erin. It is all of the above. It's E. Yes, I think those of you that answered F, you skipped the B, and health claim is very important. If you want to claim a high protein, put a high protein on the label, you really have to have certain, you have to have a percent daily value and a certain amount of protein in your sample in order to make that claim. So yes, health claim is very important. Not just for protein, it's just an example. Okay, so once we know what type of analysis we want to do and conduct, we need to choose a method. And to choose a method, we have to look at the characteristics of this method. So what are the characteristics of the method? And this is table 1.5 in your book chapter. You can review that table. It's good for revision. But in there, you'll see that the inherent properties of the method is very important. So when I say specificity, can any of you type in what I mean by specificity of the method? And don't tell me how specific it is, but if you can explain by giving me an example. So let's see what people would answer there. Are there people typing? Yeah, okay. For some reason I had a glitch there. Okay. Okay, so if I'm looking for a certain specific type of protein, so a method would allow me to look for a specific type of protein versus all proteins. An example there is ELISA, a method that we can use to look for specific proteins. We use antibodies and we can be looking for a specific type of protein versus a CalDAL or DUMAS. We will learn that in a couple of weeks. It will determine total protein. That's an excellent example of specificity. Yes, selecting only for saturated fat versus total fat, what the method selects for. Thank you. Not so much specificity in temperature, specificity or the conditions of analysis. Specificity is as those above examples where we're looking for a specific component that could be within a larger group, but we don't care for the larger group, like total carbohydrate versus total glucose, for example. So that is the what is meant by specificity. So this is really dependent on what we are looking for. Are we looking for total reducing sugars, or are we looking for total sugars, or are we looking for total carbohydrates that include sugars, starches, and fiber? So that is another example for specificity. Now, what do we mean by precision? Let's look again. Consistent data points, how close your result exactly. So when you run the analysis, we usually run replications, and we'll learn that next week in lab and also in the lecture when we talk about data analysis. Whenever you run an analysis, you have to run it in replication so that we account for any error. So in your statistics, you account for something called experimental error. So you replicate so you can reduce the percentage of chance, and then you're more certain of your data. So precision is how close your replications are to each other. That is precision. In terms of accuracy, then, can you type in what you think accuracy is about? Exactly, how close your results are to the actual value. So how true your values are. And then also there are statistical calculations we do to determine percent relative error. And we use that percent relative error in comparison to a true value. And then you take your measured value and compare it to your true value, and you determine how close you are to the true value. So choice of method then is very much dependent on these inherent properties of the method. Is it precise? Is it accurate? How specific do we want it to be? Okay, great. So next, applicability of the method. Okay, do we need a lot of sample to run the method, and we really have few milligrams or few grams sometimes? So the method is not very sensitive. We really need to look for another method that could potentially be more sensitive, and we can use less amount of sample. And are the reagents dangerous, have safety hazard, or are they, we can work with them and they're not very dangerous, or we can select a method that has reagents that are more safe for us to use? And then equipment, do we have the right equipment? Do we have DUMAS, a nitrogen analyzer that will allow us to do DUMAS, for example, which is one method for protein determination? Or do we have to do it the other method, the chemical method, which is CalDAL? So depending also on the equipment you have available in your lab. Usefulness, how long does it take? Is it a half an hour assay, or is it an 8 hours assay? So again, the time component plays a very important role there. Let's see. And do we really need this analysis? Of course, how useful this method is to us. Do we really need to run this assay to make a decision, or we don't? Is it going to save us time, or is it going to cause extensive amount of time? Is it reliable? Can we trust the data? Or is it a funky method that has so many steps and so many errors that might not result in a reliable set of data? Do we have the personnel that are trained, or is it easy basically to get trained on the method? Is it safe? Do we have the procedures, or we call in our labs, we call something called SOP, standard operating procedures? Do we have that? Do we have access to it? So all of these are consideration when we choose a method. Sometimes you have 3 or 4 or 5 good methods, and then it's just a matter of what's available and who's trained. That would be as simple as that, to select one method out of the 5. Uh, the objective of the method. So again, why do we want to analyze? Is this method needed for nutritional labeling, for example? Then we need something, a method that is official. By official, that means it's approved by an agency that have tested it multiple times and across labs and always got to the same end results. Then it became an official method that has been tested and approved by an official entity or an organization. Then hence the name official. And then sometimes you hear primary method. By primary, there are primary and there are secondary method. By primary method, it is the original method that secondary methods are calibrated upon. So sometimes when you want to calibrate NIR, that means near infrared instrument, in order for you to get reliable data from an NIR, which is a secondary method, you need to calibrate using a primary method. So if you want to get total fat on the NIR and calibrate it, you want to get total fat using Muginer method or Soxhlet method, and then plug in the data and have standards so that you can use the NIR method. So NIR is secondary, and then other methods, official methods, are primary. So, and sometimes you hear it is called the reference method. So official, primary, definitive, reference, they all mean similar things. And then example for that is nutrition labeling, or if you need them sometimes to validate new methods or to calibrate an instrument method that gives you fast results. So that are examples of when these primary methods are needed. So rapid quality control, they're always called secondary methods, and sometimes you need to monitor total solids while you are during processing. So you really need something really quick, like a moisture balance analyzer, or you want to get, you're producing milk with different fat levels, so the skim milk, low percent fat, 2% fat milk, and then you want to test at the end of production that you have achieved the requirement to call it skim milk or to call it 2% milk. So instead of doing primary method for fat analysis, in this case, you want to run a lot of samples through. So you want your mid-IR instrument, in this case, is commonly used, to be calibrated and ready to go and give you results in few seconds. And this is secondary method because it required primary methods for calibration. Uh, Online processing measurements, so either rapid quality control or online processing, they both really require only secondary methods of analysis. So during processing is online, and then at the end of processing, to make sure that you have the quality, like I said, at the end for labeling skim milk or 2% milk, you want quickly determine that quality at the end. Versus online looking at pH or looking at acidity and percent moisture, total solids, and similar situation. Of course, during the entire semester, you'll be given examples of these methods and which are primary and which are secondary methods. So this is just introduction. Do I have a question there? Does official method has to be under government agency or organization? Yes, they do. So in order for them to be called official method, they have to have gone through validation. And usually it's done by official organizations that have gotten government approval to be official organizations. So they would test the method and select few labs across or different across the nation or globally, where they would test the method and ensure they get similar results. And once you do that, then it's called official method or get approved as official method. Good, thank you for the question. Any other questions? All right. So again, choosing a method also depends on the type of food and the composition of food. So some foods are high in carbohydrates, other are low in carbohydrates, or they have different scale in the amount of fat or different scale in the amount of protein. So depending on the components and different moisture amount, depending on these macro components, you will decide what method works best. And during lab, each group will have a different food product. Some would be dairy, some cereal. Then you will see that, or some nuts, like almond, I believe, is one of the nuts we have tested in the past. So every type or category of food will have different composition, and we will be running protein using different methods. We will running fat using different methods. We will be running moisture using different methods. And then you will practically determine which method would suit best uh, different foods based on the component. And we're going to go over reasons why some methods are better than other in certain category, for dairy foods versus cereals versus nuts. And here's an example I want you to think about. So let's say you have um, a food product that you want to determine the amount of fat. So you want to extract and analyze fat content. So you want to extract the fat from the food product and determine the content or the percentage of fat. And the food product is high in carbohydrate and protein. So for sample preparation, when you answer, don't give me just a letter, just maybe next to your answer, tell me why you think that is the correct answer. Quickly. All right, let's have you do that. Am I getting answers I'm not seeing? Sometimes this is just funky there. All right, starting to get answers. So C is correct, but it's not the only correct answer. We definitely want to use solvent. Actually, there are methods where you don't use solvent, but most methods for most categories of food, you would use solvent, extraction of fat. Okay, some of you are including B, and yes, exactly. So sometimes you need to do acid hydrolysis, especially in the case of high carbohydrate product, because when you have high carbohydrate and high protein, let's say, the fat is entangled in them, the fat component. So the solvent has a hard time extracting the fat. So if you apply acid hydrolysis, you break down the macro components and releasing the fat into the solvent phase. Then you will get most of your fat extracted that way. Now, in terms of pre-drying, sometimes you do, sometimes you don't. So it's a tricky question here. I didn't say anything about the moisture content in this question, but if you have a high moisture content food and you want to use semi-continuous extraction method like Soxit, which you will learn about later on, in that method, the water kind of interferes in the solvent reaching the fat. So you want to pre-dry your sample if it's high in moisture, above 10%, I believe. So if the moisture content is higher than 10%, you want to pre-dry your sample for that particular method. But there are other methods where water doesn't cause a problem because of the different reagents you use, where you can really have a good separation between aqueous and organic solvent, such as a Muginer method, which you will learn about. So you do not need to pre-dry your food product. So here is a table that shows you that with acid hydrolysis, your percent fat is higher than without acid hydrolysis for different types of food. And the higher the fat content, the more difference, the bigger the difference that you would see between acid hydrolysis and no acid hydrolysis. Okay. Then also your choice of method is dependent on making sure that your method is valid. So you want to test the validity of your method. So how do we test the validity of the method? The validity of method is dependent on so many factors. One of it is the characteristics of the method that we talked about earlier, how specific, how precise, how accurate. When you run it day to day versus in the same day you're doing replications, sometimes your replications are good within the same day, and then if you come the next day, you prepared another set of reagents, and then your data is not reproducible. So not just the precision within one day, the reproducibility of your assay over time is very important. So how well your results are repeatable for the same set of samples. Is the method going to be, the data from the method is going to be representative based on the sample that you select and the number of samples you run? And sometimes to test validity of the method is not just by looking merely at precision and accuracy and repeatability of the method. You can actually get standards, uh, standard products or samples, food samples that you would run using this method to determine its validity and compare your results to an official methods. And you get these standards from the National Institute of Standards and Technology. So that they provide you with standards, and then they will tell you what the different compositions are or values of whatever you're trying to test, and then you try to analyze it using that method and assess the validity of the method that way. Also, you can have check sample services where some organizations like the American Oil Chemist Society, for example, American Analytical Chemist Society, which is now called Cereals and Grains, they can also, what they do is they offer you samples check. So they give you standards and they tell you, okay, you analyze them and then send us the data, and then we will interpret the data for you and assess the validity of your method. So they kind of provide you with a service that way. Or you can have your own internal control samples from the process during a production in a plant. You have your own internal samples that you would test regularly. So you would take these samples, and if you're testing a new method, you would run those particular samples that you've run before using different method and see if you get similar results. So that's another way of validating your method.
Pam, I wanted to make sure that you got the question about acid hydrolysis and protein denaturation.
Okay, let me see. I don't think I saw that. Hold on. Sometimes when I'm sharing, I have a hard time seeing chat unless I go there. Yeah, acid hydrolysis will cause a protein denaturation, that is for sure. But when we have a high protein product and low carbohydrate product, like for example, cheese, a sample, instead of using acid hydrolysis, we solubilize the protein in a manner using like a base, ammonium hydroxide, for example. So it kind of solubilizes the protein and prevent it from really being entrapped or entrapping the fat. So basically that will help a high protein product to be able to release the fat from it when you have low carbohydrates. So instead of acid hydrolysis, you do ammonium hydroxide solubilization of the protein. So that's a good question. We will address that in more detail in the fat analysis chapter. Okay, good. So There are different organizations, like I said, that would have approved official methods for different types of analysis and different types of food. So if you are seeking official methods of analysis for different types of food, and here, this example here in this table, it shows you so many different varieties of food, and these are approved by AOAC, and AOAC stands for currently as Association of Official Agricultural Chemists. It used to be Association of Official Analytical Chemists. They changed the name, they keep changing. I don't know if they changed it again, but it remained the same acronym, AOAC. And these are the methods. There are so many methods approved by this organization, and they are called official methods of analysis. And they always have, they update them and improve them and add to them. So you'll see several editions. The last edition is the 20th edition from 2016. That's the last one I'm aware of. Another organization is the American Association of Cereal Chemists International, AACCI. Now it's called cereal and grains, so they changed the names, but still the official methods, the approved method, are referred to right now, as I'm aware of, AACCI approved methods. And the last edition I'm aware of is 2010, and it's the 11th edition. Another one that you'll see very common is AOCS, official methods of analysis. And these are specific for oils and oil seeds type of food or related products. So for analysis of vegetable oils or animal oil or fat, and analysis of ingredients and products, for example, soy ingredients or soy related products. You'll find specific methods, for example, determination of lecithin, glycerine, soap, and so on. The last one I have here is the standard method for the examination of dairy products, so specific for dairy. So measuring fat in dairy product, or measuring lactose or moisture or protein. And this is specific for dairy, like either yogurts, ice cream, cheeses, milk, etc. So these are specific for dairy ingredients and products. And the last edition I'm aware of is the 17th edition. So that's that for the introduction. We have few more minutes. I'll start the nutrition label. Unless you have any questions before I go on. Okay, so I'll stop sharing this and start sharing the nutrition labeling. Okay. So let's take a moment as a group and try to find the correct answer. FDA stands for Food and Drug Administration. FSIS stands for Food Safety and Inspection Services. I keep forgetting. Okay. Let's see what you guys. All right. This is all me trying to get to the chat. Here we go. All right, let's keep trying. Somebody said D. A. Let's keep going. C, like that. C, no, I like that. What I meant is I like the differences that I'm seeing. So far, I'm getting all the letters. Yeah, I'm getting all the letters. You can stop now answering, because what I'm going to say, John says all of them. Actually, none of them. So good, we don't have a correct answer here. And none of these are true. Nutrition labeling is required only if a food contained an added nutrient. That would be back in 1973 regulation. That's when you would need to have a food label if you added a nutrient. But now, no, that is not true. Nutrition labeling is required only if a nutrition claim is made. Again, that's back in 1973. Now, whether or not you're making a nutrition claim, you have to have your nutrition panel on most of the foods. There are some exemptions. Showing percent daily value for protein is mandatory. No, it's only mandatory if it is for children under 4 years of age, infants and children under 4, or if you're making a protein specific health claim. But you can have it on the label, but it's not mandatory unless you're making a claim. Methods of analysis are to be determined by the manufacturer. No, for nutrition labeling, you have to abide by government regulations, FDA and FSIS, and use the whatever you have recommendation in the Code of Federal Regulations. So you need primary methods. It's not up to the manufacturer to decide. They have to go by official methods of analysis. Stating percent daily value for vitamin A and B12. No, vitamin A is currently mandatory. It's going to go away once the new format is fully in practice. Vitamin B12 has never been a mandatory. It can be optional. You can actually list all vitamins or minerals if you want on the label, but it is not mandatory. So none of these questions, none of these answers are correct. So let's go back to some history. So Food and Drug Administration regulates food labeling for all products except meat, poultry, and egg. Meat, poultry, and eggs are regulated by the Food Safety and Inspection Services of the USDA, so FSIS. So the earlier acts regarding food labeling from the Food and Drug Administration and Food, Drug, and Cosmetic Acts of 1938. So they said that, okay, so we need to put the amount of food on the package, the common name, what's the actual product is, and then the list of ingredients. That was all what was required. And then moving on to 1973, then you can have a nutrition label panel on the product, but it is mandatory if you add a certain nutrient or you want to make a certain health claim. However, 1990 Act, Nutrition Labeling and Education Act, made the nutrition labeling a requirement. So you don't only put amount of food, common name, and ingredients, you have to put nutrient content and nutritional value for most foods with few exceptions. So it went from being optional, the nutrition panel from 1973 regulations, where it's optional except if you added nutrient or you wanted to do nutritional claim. And back then, the role of calories and macronutrients were important. So you would see that the calories are there, protein, fat, carbohydrates. So the macronutrients were of importance. But moving into later years, it became that we paid attention a little bit more to also micronutrients, minerals, and vitamins, and subcomponents of fat, for example. Saturated fat versus total fat for total cholesterol. And it became required, like you said, to all food products with very few exceptions. And all of the regulations for this act and nutrition labeling is found in Code of Federal Regulations. So these are recap questions. I'll hold off on them for a second. I will project them next time. So this is your basic format of a nutrition label, which you're all familiar with. In 1990, the Act then did not include trans fat. In 2003, there was an amendment to include amount of trans fat, given the research that has indicated the health impact of trans fat. So it became mandatory that trans fat is also reported on the nutrition label. So before I go there, I had one question. I thought I had it somewhere. Okay, I might have a. What year was that? Oh, 2003. In 2003, they made amendment to include trans fat on the label. Okay, thank you, Chris. So I just wanted to pose one last question before I let you go. I said here it's mandatory for almost all food. Do you have any idea where there is an exemption for nutrition labeling? Which foods do not require mandate nutrition label? Let's see what we get. Alcohol. Yeah, let's focus on food. Yes, so yes, fresh produce, shelled eggs, yes, fresh produce, shelled eggs, UDA things. I'm not sure what UDA, USDA, coffee. Okay, let's focus on food. I was gonna say food in small packages, any fresh meat or fish or poultry, yes. Also, like if you have a bigger package and then you have smaller packages inside, you won't find nutrition label on the smaller packages. And then food intended for small children. For infant formulas, there are regulations specific for infant formula labeling. So yeah, good. With that, then I will stop here since we reached time. I will stop sharing, and then those of you that want to have a look at the lab report, please stay on. And those of you that are content and they know, and if they've seen the lab report, you can leave. I see that everybody's here. Good. Most of you, at least. All right, so I'm going to project. Let me make sure I have it open. All right. So I'll project my screen again. All right. Again, just have a look, take notes. Please don't take a picture just for sake of you creating the work on your own. I just want you to have a look with me here and take notes. So descriptive title is what you're asked to put together. In this case, this person was creative, preparation, analysis, and reverse engineering of nutrition labels using TechWizard. So it's important to state, for example, the program and what you have conducted. You don't have to have the exact same title. You can say nutrition labels of yogurts and cookies using TechWizard, a program. Yeah, so this is just an example. You do not have to have an elaborate paragraph describing your results. You're not requested, but this person decided to just write up a little bit about what we're looking at. But what you really need is your figures. So these are your figures. You need 4 figures. So like I said earlier, you will have your nutrition label and then list of ingredients underneath. And then it would be your first figure. So figure 1, you'll give it a number. So figure 1, yogurt formula 1, nutritional facts panel or nutritional label, either one is correct, and ingredient list. Don't forget the ingredient list. It's part of your figure. So your legend needs to be complete, describing everything in your figure or everything we're looking at in your figure. And then the figure 2 with another label or legend, figure 3 and 4, all of your yogurt formulas. So for example, yogurt formula 3 had the 50% calcium, the 4 had the 100% calcium. Then the table summarizes, so you need one table that summarizes differences among the formulas and differences in the label. So if the calories are different, so you would list that. If the total fat is different among the four, you would list it. Saturated fat, sodium, whatever you have, when you look at your labels, just look at the components that are different and then you would put it in that table. If you use abbreviation, make sure you have that listed or defined in the footnote. So calorie or nutrient, and then here they said amount per 170 grams serving. So that was very specific. All right, I'm getting some questions here. Let me see. This morning in lab, someone mentioned that if we choose to write the ingredients in caps, then all text in the list needs to be in text. This example shows text in parentheses in lowercase. In capital. So really, in capital or small letter, lowercase, it really doesn't matter. The ones between parentheses, this is a description of the ingredients. So you have milk, 3.7% fat, and then you have milk skim condensed. As long as you differentiate, I'm not sure that it is necessary to have those all in caps. You could, so that you can differentiate between what's outside of the parentheses and what's inside of the parentheses, but it's not really a major thing here. But you can't have, for example, ingredients, milk, skim milk, milk, sugar. You have, because you can't have two ingredients called milk. You have to differentiate what they are. Okay, I hope that answered the question. Moving on, after the four figures and the table, you would need to show sample calculation. So in your lab notebook, you should have done the calculations for 100% daily value for calcium. In the manual, it gives you an example for the 50%. So here you show with the units the 100% daily value calculation. For every lab, there will be a unique set of calculations we'll ask you to include in your results section. Okay, I have another question. Should their Formula 3 and 4 indicate they are based on Formula 1? You could. I mean, it's not a necessary, but it makes your table complete. I think it's a good idea to have a footnote saying Formula 3 and 4 are based off of Formula 1 with the exception of addition of calcium. You can do that. That makes it even more thorough. Do we have to write reverse engineering observation and the results? I was coming to that, Irene. In our lab report, do we need to include the 100% calculation, because the 50% is already in your lab manual. So the 100% is what you have calculated and put in your lab notebook. So you would show that example. And to answer Irene, I was coming to that. So you can see where I am putting my cursor here, reverse engineering observation. So in the lab, when you were running the lab and you got to reverse engineering, you were taking notes, I hope, in your lab notebook of what you were observing. So you would use very briefly a couple of sentences of the observation, of your observation, the different steps that you've seen. And then you provide the importance of such an application, reverse engineering. What's the importance of it? And in which circumstances one would utilize reverse engineering. So it will be good to just summarize that. As you can see here, it's a small paragraph, not a lot of, to go into detail into. And then after you're done with the results, there's the question sections. Make sure to show calculations. Do not put just a number, because we want to see that you actually went through and figured out that amount or that value and what equations you've used. Sometimes you've done the right, you used the right equation and you have missed just some like a zero here or miscalculation there. So instead of losing points on the whole question, you would potentially get points if even if you get the wrong answer because your equation was correct. And then after, and question 5, like I said, is the cookie question. Do not put the cookie figure in the results section. It goes here in the question section. So it's the same thing. You generate a figure and it will be figure 5. You make sure you label your figure 5, and give a figure legend for it. And then lastly, in this case, you will list your appendices. So in this particular student case, their appendices had the nutrition facts panel and ingredient list of the formulas. So again, I explained earlier that in this particular lab, the data is the same in the raw data and is the same in the results section. So appendices, usually we attach our raw data, and your raw data in this lab and only this lab is the same as the results. So you have your figures in the results, and in the appendix, you also put the same labels, but you don't have to give them figure numbers and figure legends. So it's the exact same. Whatever you copied and paste into a Word document and email to yourself before generating the figures, these would be your raw data. So it's the exact same, and I know it's confusing. It's just the only lab that is like that. Later on, there will be real distinction between the raw data and your summary of results in the results section. And then your appendix B, if depending on which product, in this case, chocolate chip cookie, you might select a biscuit or whatever that you would potentially use the Tech Wizard program to generate a nutrition label for that product and compare that nutrition label that you generate with the Tech Wizard with the actual nutrition label on that product. So you will have an image of the nutrition label of the product that you chose, and then the nutrition label you generate with Tech Wizard, and then you provide a couple of sentences if there are differences, why you would think, what were the challenges that the one that you produced is a little different than the one that was on the product. And again, this is for +2 on the lab report. It's not an obligation. It would be good to do because that could be a nice exercise for capstone later on. So we don't need the nutrition label pics for raw data area, just a note of creation. No, you do need. I'm sorry if that wasn't clear. That's why it's confusing for this lab report. The nutrition label, you would use it twice, once in the results section and then in the raw data section in the appendix. The only difference between the two is that in the results section, you actually give it a figure number. You have your label, the list of ingredients, and underneath you give it a figure number and you give it a figure legend, a description of the figure. In the appendix section, you have the same label for all of the different, you would have the labels for all the different yogurts and cookies. Oh, here in what I'm projecting, yes, I don't have the attachment. In the past, we didn't have them upload, last year, we didn't have them upload their lab reports online. So this was just a scan of a lab report. So I didn't scan the appendix. So that's why you don't see here the rest of the appendix. So I did not scan it. It was underneath here. So you have your labels, you put them, you attach them. After you list your appendices, you attach them. So the next page would be your labels, but without a figure. Is that clear, Chris? Yeah? Crystal? Okay, good. All right, any other questions? All right then. If you think of other questions, you can email me between now and next Wednesday for the lab report. Otherwise, I'll see you on Friday. Thank you.